Good afternoon, all. Welcome back to our course on the C programming language. In today's session, I'm going to discuss about the unions in C, but this is related to part 2. So in the previous session, we have seen the part 1 of unions in C, where we have seen what a union is, and similarly we have seen how to define a union and how to declare the union variables. In today's session, I am going to discuss a very simple topic of the memory allocation for the unions. This particular concept is very important. Why? Because we know that under the user defined data types, we have structures and unions as the major concepts. So we should know the difference between the structure and union, and while you learn the differences between the structures and unions, you always learn the memory allocation or the total memory allocated for the structures and what is the total memory allocated for the unions as the first point. So in this session, I am going to discuss about what is the total memory that is allocated for a union. If you go for the concept of structures, the total memory allocated for the structure is equal to sum of memories allocated for individual data members. So what we will do is, for example, if we have members 1, member 2 and member 3, let us assume that a structure has these 3 members, and assume that the size of member 1 is x and the size of member 2 is y, and the size or the memory allocated for member 3 is z. So if you want to know the entire memory allocated for this structure, you just have to add the memories that are allocated for different members. So it is nothing but x plus y plus z. This is the generalized thing I am saying. But while you come to the concept of unions, very important point, the size of a union is equal to the maximum size of a member. Maximum size of a member. So it is not going to allocate memories for different members. It is going to allocate the memory which is equal to the size of the highest member, and that memory will be utilized by all the members, or they will share, all the members will share the memory location. For example, if you take the same concept of having 3 members, so member 1 is having a size of x and member 2 is having a size of y, and member 3 of a union is having a size of z. Let us assume that this is a union. These are the 3 members of the union, and let us assume that x is greater than y is greater than z. That means the memory occupied by member 1 is greater than the memory occupied by member 2, and in turn it is greater than the memory occupied by member 3. So here the total memory that is occupied by the union is equal to x. Why? Because by this relation we came to know that x is having the highest memory allocation. So the total memory allocated for the union will be equal to the maximum size of a member. Very important point. So let us see this with an example, a very simple example. Let me take a structure first. So I define a structure student, and let me say it has the first member as a registration number which is of type integer, and the second one is a character which is it is a gender which is of type character, and the third one is, let me say that it is double and CGPA. So the third member is CGPA, which is of type CG double. And let me create a variable of this struct student. Let us say it is S1. So if you don't specify, or if you won't declare this S1, for example, let me assume that I don't declare this. So by this point, the compiler will not allocate not even a single bit of memory for this struct student data type. When you want to allocate the memory, then you have to declare the variable for that particular data type, which is nothing but struct student. So I have created S1 and S2. Let us assume. So S1 will be allocated memory and S2 will be allocated separate memory. How much memory will be allocated for S1 and how much memory will be allocated for S2 is dependent on this particular formula. So it is the size of the structure variable, or the structure is equal to sum of memories allocated for individual data members. So we know that the size of integer is 4 bytes. Similarly, the size of character is 1 byte, and the size of double is 8 bytes. So for S1, the total size allocated will be equal to 4 plus 1 plus 8, that is 13 bytes. So a total of 13 bytes will be allocated for S1 and a total of 13 bytes will be allocated for S2. And remember that for S1, let us assume like this. This is the memory allocation we have. So 4, 1 and 8. So this particular 4 bytes is called as registration number, this is gender, and this is CGPA. So this is 4 bytes and this will be 1 byte and this will be 8 bytes. Right. And similarly, if you consider this S2, let me draw another memory location like this. This is 4, this is 1 and this is 8. So this is the registration number of S2 and this is the gender of S2 and this is CGPA of S2. So this will be 4 bytes, this will be 1 byte and this will be 8 bytes. So if you observe here, a very important difference is S1 and S2 are having different allocations. And the two S1 is having different allocations for its members like the registration number, gender and CGPA. Similarly, S2 is having its own memory allocation for all the members like this registration number, gender and CGPA. You can see here, this is 1000 memory location has been allocated for S1, and from 1000 to 1012, which is equal to 13 bytes, is allocated for S1. Similarly, from 2000 to 2012, that is 13 bytes will be allocated for S2. Always remember that every member of the structure will be allocated separate memory locations, so that you can always deal with different members of the structure at the same time. We'll again come back to this concept when we discuss the differences between the structures and unions. But let us confine our discussion for this particular session that every structure will have a memory that is equivalent to the sum of memories allocated for individual members. In this example, it is just 13 bytes. Now let us take the same concept where I have declared or where I am defining a union. Let me take the name of the union as also student, and let me take the same members, that is registration number, which is of type integer, and gender, which is of type character, and last one is the CGPA, which is of type double. Let me end this. Now I want to create a variable here, union variable. So I make use of this union student data type, and let me say that I create two variables, union variables S1 and S2. According to the formula of the total memory allocated for a union, we know that it is equal to the maximum size of its own members. So how much memory will be allocated for S1, how much memory will be allocated for S2? So let me explain this. This int registration number will have 4 bytes and gender will have 1 byte, and similarly CGPA will have 8 bytes. But remember that the maximum size data member is the CGPA, and therefore the total memory allocated for the union is equal to 8 bytes only. Very important point. So how much memory will be allocated by this for this S1 is nothing but it is just 8 bytes, the maximum sized element. Similarly for S2 also you will have the 8 bytes that are allocated. Of course they are of different memory locations. Let me say that 3000 is the base location of S1 and 4000 is the base location of S2. So it will allocate a total of 8 bytes, therefore the end byte will be 3007 and here it will be 4007. So this is how the memory will be allocated for S1 and S2 which belong to the union data type. So always remember that the memory allocated for a union variable is equal to the memory allocated for the maximum member of its union. So this is all about the memory allocation for the unions, and all the 8 bytes are the maximum sized byte or the maximum sized memory that is allocated by the unions is equal is allocated in the contiguous memory locations, similar to that of arrays and structures. There is no doubt about it. So that's all for today's session, and let us have a quick recap of what we have discussed in this particular session. So in this session I just have concentrated only on one point, that is the memory allocation for the unions. So I have started my discussion with what is the memory allocated for the structures. The memory allocated for the structure is equal to the sum of the memories allocated for the individual data members. So I have taken an example like this, or structure with 3 members and XYZ are the memories allocated for those member variables, and the total memory allocated for the structure is equal to X plus Y plus Z. And if you take the concept of unions, the same union I have taken same 3 members with X, Y and Z memory allocations, and we have the relation that X is having the more memory locations than the Y, and consequently it is having more memory locations than Z. So the total memory occupied by the union is equal to X, which is of maximum sized member. So I have compared the memory allocations with 2 examples of structure and union. The same members I have taken, I have created 2 structure variables, and I have shown how and what memory is allocated for the structure variables S1 and S2. The same thing I have taken for the union, and I have shown how this memory and how much memory will be allocated for this S1 and S2, that I have explained it clearly. So that's all for today's session. Thank you one and all for joining the session.